Okay, so I'm going to jump right into this. And Leja's joining. Rational exponents. So get your paper, pencil, as always. Get your calculator ready, hopefully. So just keep in mind the stuff we learned last week, the product rule, the power to a power rule, like the quotient division rule. For exponents, all that stuff still applies. We're going to be needing that information still, and we're going to add on one more concept for today. This concept is not always the easiest one for students to get the first time. So the good news is, considering that can be a challenging topic, that it is what we're doing today and tomorrow and Wednesday too. Not just one mastery test and one lesson, but it is all the same topic with not too much extra tomorrow or extra on Wednesday. So give it your best shot today. Ask questions if you have them, when you have them, and we will do this together. So rational exponents. So to start, I want to recall what square roots are. Let's practice these 4 square roots that we see here. So does anyone remember how to take a square root or simplify a square root or figure out what a square root is of some number like these ones I've got here? Please. We haven't done them together in class, but I know you've all seen them before in your other earlier math classes. Any ideas? Can you guys hear me okay? Or am I okay. Okay, very close. You're on the right track. We're not quite dividing the number inside the box by itself, but it's related to that. Okay, so thank you so much for throwing that out there. Let me get this going. So we're not dividing it. Let me get my pointer on here. Here we go. But we are asking the question, what's the number? Let me write this down here. Okay, things are acting weird on my screen today. Perfect. Sorry, everybody. Let's try this. Okay, now it's working. Okay, so to find out what a square root of some number is, and I've got 4 of them here listed to practice with. Square root of 4, square root of 9. We're asking the question, what number multiplied to itself makes a 4? What number multiplied to itself makes a 9? What number multiplied to itself makes a 16? So it is not always direct. Like you can't just divide it or subtract something and go straight to the answer. You've got to kind of do some background work thinking about which numbers. So one way to start this is to just do a list on paper somewhere. 1 times itself, I'm going to write it as 1 squared, is 1. 2 times itself is 4. So that means the square root of 4 over here on the left, that's 2. 2 times itself gives us a 4. And if you just kind of keep going with the list on the right in red, 3 squared, well, that gives us 9. So that means the square root of 9 is equal to 3. And the next ones I've got are 4 and 5. So 4 times 4 is 16. So the square root of 16 is 4, and likewise with 5. And we can kind of keep going. There's an infinite number of these square roots to find, but this is just some examples. I wanted you all to see this and start thinking about it again and notice this concept here, taking the square root of any number, it's undoing squaring. It undoes squaring. So think about square rooting like this box and taking it here. I'm going to write it as x. So square root of x and x squared, these are opposites. Opposite operations, just like adding and subtracting are opposites. Just like multiplying and dividing are opposites, these two guys are opposites, squaring and square rooting. Any questions or comments right now, please? Okay. Now, the topic today is called rational exponents. Um, and what that means is fraction exponents. So rational numbers is just another math word. It's a fancy word. That means fractions. So anytime you see rational numbers, what we mean is a fraction, something that can be written as a fraction. So that's what we're doing today, are exponents that are a fraction itself. Last week we did a lot of whole number exponents. We saw negative numbers as exponents. We saw zero as an exponent. And now we're looking at what it means to have a fraction exponent. And it has to do with doing square roots. So rational exponents, fraction exponents, it's another way to write square roots. Which we'll see in a moment. So here's a definition. So make sure to write this down. I'm going to circle it, very important. Any number x to the 1/2 power is equal to the square root of x. So now I'm going to rewrite my square roots from the last screen. Sorry. So we looked at square root of 4, and we know that that means it's actually equal to 2, but I'm going to rewrite it using the fraction exponent now, the rational exponent. So this is the same thing as 4 to the 1/2 power. 9, square root of 9 is 9 to the 1/2 power. And root 16 is 16 to the 1/2 power. So I want you to start thinking about, if I see a square root box, we can switch that and convert that to the 1/2 power instead. It's still like the base is 4, and then we see that's the number inside the radical box. That's what that square root box is called, because it's is the radical box. 9 and 9 is still inside there. 16 and 16 is inside there. So think of this as a definition. Square root box, you could rewrite that as the 1/2 power. Okay, let's do a couple examples with different stuff, different bases inside the radical. And I'm just going to convert these, writing each power expression in radical form, or writing the radical into power form. So I just want to go back and forth. These are all equivalent to each other. So 12 to the 1/2 power is the same thing as square root of 12. 3x to the 1/2 power, that'll be the square root of 3x. 40 square root, that's the same thing as 40 to the 1/2 power. There's not one right way to write these or express these. They're just the same as each other, just whatever is useful for us while we're doing a math problem. Sometimes we'll want it in radical form, and sometimes we'll want it in exponent form or power form. And then 8x, square root of 8x would be 8x to the 1/2 power. And notice that I'm bundling those together with the parentheses, because 8 and x are both getting the square root taken. And I probably should have done this on the last slide. I'm just going to label my 12 example on top. This is power form because it has an exponent, a power. And then on the right, we've got the square root of 12, and this is called radical form. Because the square root box, another name for that, is the radical. Okay. Now, we're going to bump this up a level in complexity. So stick with me. And if you have any questions, interrupt and tell me, please. I want to hear. So other roots can also be written as exponents. And this may be the first time you're like hearing or seeing about other roots at all. So far, we've only really talked about the square root. But what about this case here? This is pronounced the third root. Third root. Why? Because we got that little 3 symbol right there telling us it's the third root of whatever's inside the box of x. So we would say the third root of x. And how do I express this as an exponent form, a power form, instead of a radical form? Here we have it again, the third root of x. This could be written as x to the 1/3 power. Couple quick other examples. This would be the fourth root because it's a little 4. Fourth root of x, and we could write it as x to the 1/4 power. Basically, no matter what the little number is outside there, that's telling you which root you're taking, the third root, the fourth root, the fifth root, and it could be rewritten as the 1 over that root number power. Any questions right now, please? And also, we're going to talk about how to solve different roots like this. So in the beginning, I opened with a few square roots. Those are the first ones we learn about, is square roots. Now you're at the point where you're learning about other numbered roots, like the third, fourth, fifth, anything you want, really, any different root, and how we simplify those, how we find those. So we'll see examples of this today with numbers and not just like of x, not just roots of x. Okay, this is important. I'm going to box this. So here's our general rule. I'm bumping it up a notch from earlier. X to the 1 over n power, no matter what that n is equal to the nth root of x. So remember, x and n, those could be anything. They could be numbers, they could be other variables, but this is what it means. So make sure to have this down in your notes. X to the 1 over n power is equal to the nth root. I'm going to write that down. The nth root of x, okay? I'm calling it n and not a specific number because this is general. So it could be that x to the 1 over 100 is equal to the 100th root of x, or any number you want. Okay. I'll wait a few moments. Looks like people are still copying or writing. And I want to look at some actual examples of how to simplify the third root or the fourth root, other roots other than the square root. Here's a solid example. Like, what do we even mean by the third root of a number? Okay, so earlier we looked at square roots, and that means, so I'm going to quickly just go back to that. First page here. So we looked at these square roots, and I told you that to solve a square root, we're looking for the number that multiplies to itself to make the base that's in the box. So the square root of 4 is 2. 2 times 2 is 4. So 2 is the square root of the number 4. Those are multiplying together just twice, right? 2 times 2 is 4. So 2 is the square root. So if the root's different, like in this case, we're looking for the third root, then we're asking ourselves what number multiplies to itself 3 times to make an 8? Now, I don't expect you guys to just like know that off the top of your head. I don't either. I have to stop and like figure out these kinds of problems myself. Sometimes you might know it, and that's awesome, but be prepared to have to like go through a process to figure out which number multiplies to itself 3 times to make whatever's in the box there in the radical sign. 2. Yeah, I heard 2 people with that answer. Nice. Thank you both. So you guys, no, go ahead. Go ahead, please. Well, I'm glad you both jumped in there. I'm sorry. I know there's not a really good way. I don't want to have everyone like raising their hand, but maybe we should do that. Just because I don't want people to cover each other either. I appreciate you both jumping in there. Now you both figured that out. I want to show you a quick way to figure out this type of problem and any more complex one. So here's how I would like to approach problems like this. If you don't see where they got that 2 from. So I take the number in the box, the base. In this case, it's 8. I'm going to write it down on the side somewhere. I'm going to do a factor tree to figure out all the different numbers that multiply to make 8, like this. So start with anything you want. Start with 2 is usually a good choice if the number's even. So I'm going to say 8 divided by 2. Well, that's 4. So I'm going to make this root system here. This is my factor tree to break apart the base, the 8, and figure out all the factors that multiply to make it. So 2 times 4 is 8. Perfect. Can I break 2 down any further? Not really, because 2 is just 2 times 1. So when I get to a prime number where it's just a number times 1, I'm going to circle it and ignore it for now and move on to the other options. So 4, can I break that down further? Yeah, that's 2 times 2. So what we've done here is just rewritten 8. 8 is equal to 2 times 2 times 2. How do I write 2 times 2 times 2 with exponents? 2 to the 3rd power. So check this out. This is how it's best to go about problems like this, I think. So back to our actual problem. It was the 3rd root of 8. So I'm going to convert this problem, into power form. So this is 8 to the 1/3. Now, we've done that side work with our factor tree, right? And I figured out that 8 is actually equal to 2 to the 3rd. So watch, we're going to substitute in 2 to the 3rd for our 8 in the actual problem below. So 2 to the 3rd to the 1/3 power. I switched out 8 with 2 to the 3rd. Now, our rule from last week was outside powers multiply to inside powers. So it's like this 1/3 is being multiplied to the 3. So that's 3 over 3, right? But 3 over 3 is a 1. So our exponent is going to kind of dissolve and disappear here. It's 2 to the 1, which of course is just 2, which is what those 2 folks answered with earlier. Now, you might think that this is a lot of extra work to do for this problem, and you're probably right, okay? But this approach of starting with the factor tree, so right here, start here, we took what was inside the box and we broke it down to its factors. Then I'm going to rewrite my problem into power form here. Then I substituted in my 8 as 2 to the 3rd because they're equal. So that's a legal move, right? Then I multiply in my powers and simplify. And this will work for like all the problems, not just the easy ones like this. So that's why I'm showing you. Any questions or comments, please? Okay. Let's look at another. The 3rd root of 216. So I'm going to start with my factor tree, 216. Okay, I'm not a genius, okay? I'm just a human being. I don't know what all the factors are of 216, so I'm going to trial and error it just like you are. We're going to take 216, we're going to divide it by everything. whatever works. So 216 divided by 2. That worked. I got 2 times 108. 2's done. It's a prime number. 108, let's keep going. Divide that by 2. 2 times 54. 54 divided by 2. 2 times 27. Okay, now this is interesting. 2's done there. 27, that's not it's not an even number. So I can't divide 27 by 2 because I get some weird decimal. We are only interested in the whole number divisions. So let's divide it by 3. If 2 doesn't work, bump it up to 3 and try that. 27 divided by 3 is 9. And then, of course, you're thinking 9 is 3 times 3, so we're done. So what we've just done is found all the different factors that multiply together in a string to make a 216. It's kind of like a unique identifier. All numbers have a specific collection of numbers that make them up through multiplication. So here's what I did. We're going to rewrite 216 as 2 times 2 times 2 times 3 times 3 times 3. And I'm going to clean that up a bit right now. I'm going to say 2 to the third times 3 to the third. Any questions on where I got that? 2 to the third, 3 to the third, please. Okay, so now we can imagine swapping out our 216 in our problem with this expression that we just found. So what do we really have here? We have the third root of 2 to the third, 3 to the third. If you put this into power form, then we're looking at 2 to the third, 3 to the third, to the third power. Now we do what we did last week. We multiply our outside power to these third powers inside. Okay, and then just like the last problem, they're going away. They're completely dissolving. 3 over 3 is 1. 3 over 3 is 1 again. So we're just left with this 2 to the 1, 3 to the 1. They're being multiplied, so that's 2 times 3, 6. So our final answer, our simplified form here is 6. I'm going to stop really quick and ask to see everyone's screens so we can do thumbs. I want to see how you're feeling about these, what you've seen so far here. So let me, really quick, I'll stop sharing. I want to see how you guys are feeling. Manaya, thank you. If you're feeling iffy on this, give me a sideways thumb. If you're really bothered, give me a down thumb. If you feel confused and need extra, Leja, thank you. Aaron, I see that. Thank you. And Jayla, thank you both. And that was, yes. Hunter, I see your thumb. Thank you. And Delaney. Okay. Okay, folks. Keegan, I appreciate that. Thank you. All right, folks. That's everybody. All right. So I just want to know where we're at. Like I said in the beginning, this is definitely tricky. I don't blame you. Took me years to feel comfortable with this too. So it's 10:30. I was hoping to have gone faster. Like my problem so far that is I'm going too long through these lessons. So that would give us more time to do the test together. So you know what? We're not ready to just jump into the test, obviously. Let's keep going. Let's do more work on this together. And like I've been saying, if you have questions, please, please, please jump in and ask. The good news is this is going to be our topic for most of the rest of this week. Today, tomorrow, Wednesday. So we can take our time with it. Let's try another one. Okay, it's a bigger number. We're doing the fifth root of 1024. So this time we're looking for numbers that multiply to themselves 5 times to cancel out with this fifth root. So how we say this is fifth root of dot, 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 whatever's in the box. 1024. Fifth root. So how do we start? We're going to make a factor tree for 1024 somewhere on some scratch paper. Start dividing 1024 by stuff. It doesn't always have to be 2. It's just easy for me to always start with 2 and then divide by 3 and then divide by 5, all the low numbers. So 1024 divided by 2, 512. And I just like to circle my 2s and 3s and 5s when I get to them, so that I know it's part of my products that I'll need to multiply. It's part of the 1024. Okay, 512 divided by 2, 256. Just keep dividing until you kind of run into the end of the road. When you get to numbers that are prime, that are only divisible by themselves in 1. So 256 divided by 2. Okay, that'll be 64. 2 times 64. And if you ever recognize another multiplication and you don't have, you can feel free to divide it by something else other than 2. I recognize 64. That's 8 times 8. So I'm gonna say that at this point. Oops. I don't like what I just did. I recognize that 64 is 8 times 8. So I'm going to do that instead of 2. It kind of will make it go a little faster. We just saw from 2 problems ago that 8 is equal to 2 times 2 times 2. So each one of these 8s is 3 2s. So I'm just going to kind of write it like that to save a little bit of time. And I'll circle these guys because we know to have our eye catch them. Now, how many 2s is this? So just count them up. It's 4, 7, 10, it looks like. Okay, so that means 1024 is equal to 2 to the 10th power. We did all that background work so we could make 1024 more easy for us to work with, because we're living in a world of exponents, and I want to cancel exponents whenever I can, like we've been doing. So now to our actual problem. The fifth root of 1024. We just solved what 1024 is equal to. It's 2 to the 10th power. So I'm going to write that, substitute that in. If I convert my radical to power form, this is 2 to the 10th raised to the 1/5 power. Remember, the number on the outside? That's 1 over that number, 1 over n power. Now what do? Multiply the outer power to the inner power. So that's 1/5 times 10. That'll give us 2 to the 10 over 5. And then simplify or reduce that fraction. So 10 over 5, well, that's 2 itself. So this is 2 to the 2nd power, because 10 divided by 5 is 2. And this is correct, but we can figure out what number that actually is. 2 to the 2nd power, that's 4. So our final answer here, is 4. Okay. All right. No questions. If there are, tell me. We're going to try some more. Okay, so far we've only looked at rational exponents when it's 1 over a number, right? The third root, the fourth root, the fifth root. So how do we do this with other fractions? Well, here's our generalization. So make sure to copy this down. For any number x to the a over b fraction power, fraction exponent, it converts this way. So the b root of x to the a power. We're going to see some examples with actual numbers now. So far, we've only seen 1 over a number, but now we need to be prepared for other fractions too, because there's like a world of fractions out there. We're going to see problems like this, where it's not just 1 over, but 2 over 3 power, like we have here. So this example is 8 x to the 4th to the 2/3 power. Now, how do we go about solving this or simplifying it? Well, let's see. Remember, 8 and x to the 4th are both going to get the treatment. They're both, going to get the 2/3 power. So one way to start would be to hand out that outer exponent now. Remember, 8 doesn't have an exponent, so I'm going to treat it like it has a 1. Now let's hand out the 2/3 power to both inner powers, meaning multiply them. So we have 8 to the 2/3 times x to the 4th to the 2/3. So those get multiplied. So it's 4 on top times the 2. So 8/3. Okay, now let's deal with the whole number. We've only done whole number examples so far. 8 to the 2/3 power. So I want to still do a factor tree for my numbers, for the base number of 8. Anytime we've got a number being raised to one of these fraction exponents, start doing the factor tree. So 8, we already know, is 2 times 2 times 2. So that means 8 could be rewritten as 2 to the 3rd. So we have, let's switch out our 8 for 2 to the 3rd. I'm going to do that here. 2 to the 3rd. I'm going to use a parenthesis to bundle that together. And then I've still got the 2/3 hanging out outside, right? I've carried all that down. And then x to the 8/3. We'll deal with that in a second. We'll do this in parts. Let's do our 2 to the 3rd to the 2/3 power. So I multiply the inner power to the outer power, and we get 2, what is that, 6/3. I'm only dealing with the 2 right now. We'll deal with x in a second. Looking at the exponent now for my 2, it's 6 over 3. Simplify that. 6 divided by 3 is 2 itself. I'm going to continue here. So that's 2 to the 2 times x to the 8 over 3. 2 to the 2 is 4. Okay, so we've made a lot of progress. We've simplified the 8 to the 2/3 power. We still have to deal with this x. So here's how I want to approach this. Actually, I'm going to, darn it, let me think about this. I made this example yesterday, and now I'm seeing I wish I would have started with something a little different. Let's do this. I'm gonna undo a little bit of my simplifying that I did from earlier. So we're gonna leave 4 alone. But remember earlier, back at the beginning, I multiplied in my 2/3 power, right? It started as x to the 4th. So I'm going to kind of undo that right now. And we'll see other examples where this will work out differently. We won't have to undo it. So I'm going to back out my 2/3 power for now. So this is more like how it started, x to the 4th to the 2/3. I want to break up my x to the 4th into little chunks so that it matches up with whatever the denominator is in that rational power, that 3. So whatever the fraction is we're dealing with in that problem, I want to break up my x to the 4th to kind of match that if I can. So here's what I mean. I'm going to separate out x to the 4th into its smaller sections, into groups of 3. So here's x to the 3rd and x to the 1. So what I'm doing is rewriting my x to the 4th into chunks that will better suit me. I'm breaking out chunks of 3 because of that denominator of 3. And remember, this is the product rule from last week. X to the 3rd times x to the 1, that's the same thing as x to the 4th. We would add those exponents. Okay, now if I multiply my 2/3 power in to those guys, to those powers, we get x to the 6/3 times x to the 2/3. X to the 6/3, we saw that a second ago with the 2, that becomes a 2. So we have, I'm going to continue here, 4 times x to the 2nd times x to the 2/3. So whenever we reach a spot like this, I've got a whole number. I can't do anything more there. I've got x to the 2nd power. There's no more fraction, so that's much cleaner. And then we've got x to the 2/3. Because that is not a number and I can't figure out what x is, right? Like it's not 8 or 4 or something I can work with. It's a variable. And because our fraction exponent is now less than 1, right? 2/3 instead of 8/3 like it was earlier, we're done. So the answer to this is going to be 4 x to the 2nd, x to the 2/3, or I'm going to circle this. We can convert that 2/3 back to radical form, and we'll see answers in both ways later in the mastery test. So it would look like this. 4 doesn't have a fraction exponent, so it's outside the radical. X squared doesn't have a fraction exponent, so it's outside the radical. But x to the 2/3 is a fraction exponent, right? So I'm going to convert that back into radical form. 3rd root of x to the 2nd. So both of these are two different ways we might see a solution, an answer. They're both valid. Okay, I'm kind of feel bad because I realized that example might not have been a good one to start with for this concept. So I want you to hang in there. Let's try a few more. Today, I think we won't be assigning the mastery test. I just want to do more examples with you. And if you want to ask, I want you to jump in and ask any questions. Okay. Here's another type of problem we might run into. Simplify x to the 1/2 times x to the 1/5. So really, this is almost like a product rule problem. We've got the same base, right? X and x. So in theory, our exponents can be added here, but we've got these terrible fractions. They're not whole numbers that we can easily add. So let's see what we can do to clean this up a little bit. X to the 1/2 times x to the 1/5. Well, we know that because of the same base, we can add the fractions. So I'm going to show that here. So what we really are going to do is x to the 1/2 plus 1/5. Those are bundled together kind of, right? That's happening up in the exponent space. So really this is just a problem with adding fractions. And we had to remember, I can add these two exponents because the bases are the same. So let's really quick add the two fractions and see what our actual answer is. Remember, when we're adding or subtracting fractions, they have to have the same denominator. So to deal with that, I'm going to multiply the 1/2 by 5 over 5. And we're going to multiply the 1/5 by 2 over 2. When we do this, we're forcing the denominators to be equal. So this comes out to 5 over 10 plus 2 over 10. Now we can add the numerators. Remember, what we have here is 5/10 plus 2/10. So how many tenths is that? It's 7/10. So that's why we're adding the numerators together. So it looks like what we have is x to the 7/10 power. This is our answer. Or we might see it written in radical form. So remember, to convert this to radical form, the number on top, the 7, is still a power for the base. The number on the bottom, the 10, is the root. So whatever the number on the bottom is, that's the root. That's the number that goes with the box on the outside. 10th root of x to the 7. So these are both valid ways to write our answer for this. Questions or comments? Concerns? Okay, let's look at another. This will be a good one. We have 27 times 40, both to the 1/3 power. So one way to do this would be to start by multiplying the 27 and 40. But because remember how we start these problems when we want to simplify them, if there's a number like 27 or 40, we want to start by doing the factor tree. So honestly, it's kind of better for us that it's already broken up. It's already a number times a number. That's a little better for us. It's going to save us some time. So this way we can do factor trees for just 27 and 40 instead of whatever that is together, which is huge, right? 27 instead of 1080. So I'd rather do a factor tree for a smaller number. So let's start by doing that. I'm going to take 27 and break that up. And then somewhere else, I'll take 40 and break that up into its factor tree. So just a reminder, whenever we're doing a fraction exponent of any number that's not like x or y or a or b, start by doing a factor tree for that number. So we can rewrite it into groups of whatever the fraction is that we're given. 27 breaks up to 9 times 3, and then 9 breaks up into 3 times 3. So 27 is the same thing as 3 to the 3rd power. 3 times 3 times 3. 40, I know that's 10 times 4. 10 is 2 and 5, and 4 is 2 and 2. So 40 is written as 2. I'm going to write it out long ways first. 2 times 2 times 2 times 5. And then put those groups of 3 things into the 3rd power. 2 to the 3rd times 5. So here's our 40. So back to our problem. I'll do that on the right side, separated it from our side work. So here's how it started. I'm going to now substitute what we just found 40 and 27 are. 3 to the 3rd times 2 to the 3rd times 5. So I just swapped out 27 and 40 for their prime factors that we found with the factor tree. Okay, now it's a good time to multiply that 1/3 in. We'll get a lot of canceling. So what we have is, sorry, someone's in the waiting room. Okay, that must be early. Oh, no, it's Delaney. So what we have is 3 to the 3 over 3 times 2 to the 3 over 3 times 5 to the 1/3. Remember 5, it doesn't have a number there, an exponent, so treat it like it's a 1. So then 1/3 times 1 is 1/3. So anything that can be reduced or cleaned up or eliminated, any of the exponents, do it now. So 3 over 3, that's just a 1. 3 over 3, 1 again. And then the 5 is kind of the odd man out here. The 5 doesn't get to clean up. So what are we left with? We're left with 3 times 2 times 5 to the 1/3. Anything without any more fractions, think of that as like outside the box, outside the radical sign. So they can all be combined. 3 times 2, 6. 5, though, has that 1/3 power. It's not just 5, right? It's 5 to the 1/3. So it's stuck. It can't combine with the 6. It can't multiply to the 6. It's going to stay as the third root of 5. So here's our answer. 6 times the third root of 5. Or, this is I like the radical box better myself, or you might see it as 6 times 5 to the 1/3. These are both legitimate. Okay, it's almost time to go. We're gonna do at least one. We're gonna do one more example, and then I'll let you guys go for today. We have covered everything that's in the mastery test. So here's what I'm gonna say. I want you all to try the next mastery test today. It's called Radicals and Exponents. Radicals and Exponents. This is the second one, the next one in a row. I want you all to try it, see how it goes. Tomorrow in class, what we're going to do is go over any questions you have from today's mastery test. We'll do some more examples, and we are going to. I'm going to have you guys like retest on it if you need to, or go over any questions you see from today's mastery test tomorrow. And then we are going to do the next mastery test after that. And it won't require a whole new lesson. It's really just more of this. Let's do this example. Example 10. So simplify x to the 13/4 power. X to the 13/4 power. So I'm going to start this mess by trying to see how best to simplify it. We could start by turning it into radical form, like this. The bottom number, the 4, that's the root. So that's outside the box. The 4th root of x to the 13. So I know I want groups of 4. So one way to do this is just to look at that x to the 13 and ask yourself, well, how many groups of 4 can I pull off of that? Can I break apart into chunks of 4 at a time instead of 13 at a time like it is now? X to the 4th times x to the 4th, that's 8 x's. X to the 4th again, that's 12 x's, right? So how many are left over? Just a single x is left over. I'll write the 1 there, even though we don't usually use the 1. But that adds up to 13. What I've done is I've split up that x to the 13 into chunks of 4. And why 4? Well, because that's the root we're dealing with this time. Now, I'm going to convert this back into power form so I can see those cancel out nicely. X to the 4th, x to the 4th, x to the 4th times x to the 1. And how do I write that in power form? Well, it is that outside number 1 over the outside number, 1 over the root number. It's not 13 over 4 anymore because I've broken that 13 up into all these smaller little chunks. 4, 4, 4, and 1. Okay, now multiply the powers together. The 1/4 gets multiplied to all those inner powers. So what is that? X to the 4 over 4 times x to the 4 over 4 a third time, and x to the 1/4. The odd man out, odd person out. So simplify these first three x's. That's just x times x times x, and then x to the 1/4. So the chunk that still has a fraction, that's going to be like trapped inside the radical box. The three that don't have fraction exponents, they're free. They're outside. They have been exited from the radical box. So here's our answer going back this way now. X to the x times x times x, that's x to the third. And trapped, we've got the x to the 1/4. This could be our answer, or do it back in radical form. X to the third times the fourth root of x. Two ways to write our answer. Okay. My clock says we've got a few minutes to 11, so I'm going to stop there for today. I am going to go ahead and say let's try doing your mastery test. So your homework is the next mastery test. Try your best doing it. Tomorrow, I want to go over questions from it that you have. So if you are doing one and it's really frustrating, or you think you got it, but then there's just one part you have a question on, write it down or take a screenshot, so that way we can do it together tomorrow in the group. Okay? Everyone's going to take the test and get slightly different questions, but they're all coming from the same pool of questions to choose from. So some of you will have the same ones, some of you will have slightly different ones, but they're basically the same type of thing. Any questions right now? Had enough math with me today? I get it. So thank you all for joining me, and I've got you all down here in attendance. So have a great Monday. Try your best on the mastery test, and I'll see you tomorrow. Bye. Thank you too.